Okay, hello everybody. Today's notes are on atmospheric relationships. These are the last bit of new information for your test, which will be on Thursday. At the end of this presentation, there will be a slide that has everything, and when I post these on Google Classroom, you will also be able to see that slide. So, atmospheric relationships are important because all of the variables that we've talked about affect each other. And it's really important for you to be able to figure out how they affect each other and draw graphs that show these relationships. So the first relationship is air temperature and the capacity to hold water. Remember, as temperature increases, the capacity to hold water increases. Capacity just means the ability to hold it. It doesn't mean that that is the amount of moisture. It just means its ability to hold moisture increases. So you need to make sure you write that relationship down next to your graph, and then we're going to draw. So we're going to write the relationship, and then we're going to draw what it would look like on the graph. So for temperature, I want you to label your axes with cold and warm for temperature, and under capacity, small and large. So cold air has a small capacity to hold water. Warm air has a large capacity. So the graph is going to have the line increasing as it moves up. So this is a direct relationship because as one value increases, the other value increases. Our second relationship is the relationship between temperature and density. As temperature increases, density decreases. Warmer materials are lighter, they're less dense, and that's why they rise. That's why warm air rises, because it's less dense. And cold things sink, so cold air will sink. So write the relationship, then label your axis, your temperature axis, cold and warm, density, low and high. Cold temperatures have higher densities, warmer temperatures have lower densities, so we have an indirect relationship. Our third relationship is the relationship between temperature and air pressure. This is kind of the tricky one, but as temperature increases, air pressure decreases. Remember that whole idea before, warm air rises because it's less dense. If it's rising off the surface, it's going to decrease the pressure on the surface. Cold air sinks, pushing onto the surface, so adding pressure on the surface. Remember, cold and dry is heavy and high. So again, label your temperatures cold and warm, and then label your air pressure low and high. So cold temperatures have high pressure, warmer temperatures have low pressure. So again, we have an indirect relationship. Our fourth relationship is between relative humidity and air pressure. As relative humidity increases, pressure decreases. So make sure you write that relationship. And I'm also going to have you write the y. So make sure you add this to your notes. Remember the analogy that I gave you of the school bus with the high school students leaving the bus and the first graders getting onto the bus. Pressures decrease because the first graders are lighter than the high school students. Same thing with air. Oxygen and nitrogen are heavy. Water vapor is light. Water vapor is a lightweight gas. So when you replace the heavy gases, nitrogen and oxygen, with water vapor, it's making it lighter, relieving pressure. So our relative humidity is low and high. Air pressure, low and high. Low relative humidity means that it's dry, so we're going to have a high air pressure. High humidity means there's a lot of water vapor in the air, so that's a low air pressure scenario. So yet again, we have an indirect relationship. Our fifth relationship is the difference between the temperature, air temperature, and dew point versus the chance of rain. The closer the temperature is to the dew point, that means you have a smaller difference. So that means you're going to have a greater chance of rain as the air is more humid. As soon as the temperature and the dew point start getting close together, that means your relative humidity is increasing, which is going to increase your chance of precipitation. So our choices are small and big difference between the temperature and dew point, and a low and high chance of rain. A small difference means that we have a high chance. A big difference between the air temperature and the dew point means that we have very dry air. So we would have a low chance of rain. Yet again, an indirect relationship. Our sixth relationship is between air pressure and the chance of rain. As air pressure increases, the chance of rain decreases. So as we move to a high pressure situation, we're not going to have a great chance for rain. It's the low pressure where the air is rising and condensing to form clouds that we're going to have the greater chance of rain. So our air pressures are low and high, and the chance of rain is low and high. So low pressure has a higher chance of rain, while high pressure has a lower chance of rain. Our seventh relationship is precipitation and atmospheric transparency, or how clear the atmosphere is. So something to think of is, remember that water vapor condenses and clings to dust particles or condensation nuclei in the atmosphere. So when it rains, all that dust falls to the surface of the earth with the water droplets. So essentially, as your precipitation increases, your atmospheric transparency increases. So precipitation essentially cleans the atmosphere because it removes the dust particles. Think of a heavy rain in the summer when it evaporates. Sometimes cars are a little dirtier because that dust has fallen from the atmosphere, and once the water evaporates, you're left with the dust particles covering your car. So again, we have low precipitation, high precipitation, low atmospheric transparency, and high atmospheric transparency. If we have a little bit of precipitation, we're still going to have kind of a dirty atmosphere. As the precipitation rate increases, we're going to have a much cleaner or clearer atmosphere. So we have our second direct relationship. And then our last relationship is altitude and pressure. And remember on page 14, the atmosphere chart that you have in your reference table, the middle graph shows air pressure and altitude. And as altitude increases, remember altitude is your height above sea level. So as your altitude or height increases, air pressure decreases. So altitudes, we have low and high altitudes. Air pressure, we have low and high. Our lower atmosphere, our lower altitudes, so lower in the atmosphere, we're going to have our highest pressures. The higher you go in the atmosphere, the lower the air pressure becomes. So we have another indirect relationship. So you might want to pause the video and take a picture of all of the notes, but again, this will be posted on Google Classroom. So these are all of the notes that are going to be covered on your test on Thursday. Going back to the introduction to meteorology and the layers of the atmosphere notes, temperature, heat transfer, moisture, changes in states of matter, clouds and precipitation, air pressure, the wind and pressure center notes, the local and global winds, and these notes, the atmospheric relationships. Tomorrow you'll get your review guide in class. Wednesday we'll review, and Thursday is the test. All right, hopefully I'll see you guys tomorrow. Bye.